You guys kept asking, and so I gotta deliver. We're coming back to PCGEx, also known as PCG Extended Toolkit, and more commonly known as PCG Extreme. Let me show you what we're gonna be going over today. And that is a Voronoi 2D pattern here that we've created using PCGEx. We're also spawning meshes, dynamically scaling to the right size. We can also dynamically change the positioning of our points here really quickly, and we even have things that cut pieces out. So I'll be going over how to create all of this using PCGEx. If you're unfamiliar with it, it is in general a free plugin you can get for yourself, thanks to its creator Tim, and of course the link to the Discord of PCGEx where you can chat with Tim and everyone else in the community will be linked in the description below. So go join it and it'll put a smile on Tim's face. And look at this smile. How can you not want to see more of this smile? But with that out of the way, let's go ahead and get started. And to get started, of course, make sure you have the plugins turned on by going to Edit Plugins, searching for PCG, and make sure you have PCG Extended Toolkit enabled and installed, as well as the default procedural content generation framework, and restart your engine if needed. We're going to start this the same way we start many things, by just right-clicking, going to PCG, and grabbing yourselves a PCG graph. And because the shape is sort of like castle walls, I'm going to call it just that, PCG_castle walls. And I'm going to go ahead and take it and drag it out into the world, and then I'll go ahead and open it. So now we can get started with creating the Voronoi pattern. Now, effectively how this is going to work is we're going to have a shape. Now, this shape can be anything, but it's going to house where all the actual cells go. So if you have an outline of a shape already that you created with points, you could absolutely already use that. In my case, I'll be using a circle, or really just using a circle generator. You can, of course, make it smoother or rougher to make it more of a octagon, hexagon, etc. And then we're also going to need some points on the insides, which are going to be our cells, which aren't going to be literally the center of the cells, but they're going to get us the right idea. But enough of that, let me show you what I'm talking about. If I go ahead and right click and search for the word shape, you'll see there are two nodes here, PCGEx shape circle and create shapes. And as you might have guessed it, we will need both. So I'll go ahead and just grab both shape nodes, the circle one and the create shapes one. And all we're going to do is put the circle one inside the shape builder here. And while the circle might be called circle, you can control how many points that circle has. So effectively, you could make it a square or triangle, octagon, etc., as I mentioned before. And depending on how many divisions you have in that circle will depend on the result you get as well. In our circle node, on the right here, you can see we have things like the start angle, the end angle, because we don't have to make it a full circle. You have the power to create just 90-degree rotations. Very convenient. Under fitting, we have the option to scale to fit something. And what is fitting? It's fitting the seed. Don't be confused. The seed in this case is not like the seed of a point, like the random seed of a point. Instead, it is the seed that grows into the tree that is the rest of the graph. It is what is the starting point. So a little bit different, but still called seeds in this case. And in my case, I wanted to use the actual full graph that we've put into the world. So I'm going to right click and do get actor data. And the only thing I'm going to change here on mode, instead of parse actor components, we're going to do get a single point. And I'm going to use that as the seed. And because of this, if I press D on this get actor data, and then in the bottom left, go ahead and select the PCG castle walls, you will see one giant white cube in the level now. And that is the full bounds of our point here. So now under circle, fitting is going to fit it to something. Instead of scale to fit minimum, it is going to fill that entire point. The entire area where this point was, this seed, is going to be filled. The circle is going to fill that point. So it's going to grow to that size, which is good for us. But I don't want to just put this in as is. There's also a resolution section. And here you can specify how many points you want. But right now it is using resolution mode distance at a resolution of 10. So if I pressed A on the create shapes, I will see that I'm creating 2,308 points. And that's just too many. So on the circle node, I'm going to go back to resolution and change the resolution mode from distance to count. And now you can see as soon as I made it count 10, the amount of points we get on the create shapes node is 10. Now, I want to take a look at these points. And if I press D to debug these points, you might see absolutely nothing in here in this default volume. Now, why is this? That is simply because the debug extents are way too small. So if I change the debug here in the scale method from extents to absolute, you can even leave it as 1, you will already see there's our circle. And there's our 10 points. And if I go select the circle, go to resolution and change the 10 to 20, you'll of course see 20 points in a circle, which again makes it so you can create kind of different shapes, like a square by setting it to 4, and there's our square. We're going to leave it for 10 in this demonstration. So great, we have the outer points. So now we want to specify where do we want the actual kind of centers of the Vornoi cells to be. And a simple way of doing that is to just put something in the world that is going to read and understand that, hey, just combine the points with this exterior and then do your magic. So what I mean is I'm going to right click and grab ourselves a new blueprint class. It is going to be of type actor. I'm just call this BP cell center. I'm going to open it up and we don't need to do anything in here. We can even leave it like this, but all I'm going to do is add a simple billboard component here. I'm going to change this sprite here to a target, use this just regular target icon, and I'll scale it uniformly by like 3x. So if I now drag this BP cell center out and go out of game mode, you can see there it is. We now have this cell center and we see it because of the billboard. It makes it nice and simple to find. And if I go ahead and click on that billboard, it is easy to select. Now, clearly this volume is going to be a bit small, so I'll actually scale it to be bigger. And if I go ahead and lock the scale and change it to be 100, so 4 times bigger, you will see because we put the circle as fill, it is automatically scaling that circle to fill the entire graph here. So now what we can do is take these points and just position them around. Now you want to get a few in here. Realistically, you want to try to go above 3. That's really when it starts to actually make shape. But we'll start with this. I have 8 of them in here and 10 in the circle. With this, I can already close this blueprint. It is no longer needed. So now we need to combine this with the other points that we created. So all I'm going to do is use a simple merge points node. I'm going to merge it with a get actor data node. And we're going to change it to all world actors by class. And it's going to be the class we just created, which is BP underscore cell center. And just go ahead and select it. And enable select multiple. If you're doing everything within the bounds, you could even turn on must overlap self. But in my case, I'll just keep it off to make it easier for myself because I'm only using 1. But down below under mode here, we're going to change it to get single point. And we're going to merge the simple data or turn that on. So now if I press A on this get actor data, you will see we have 8 points here from our 8 things in the world. So now we can merge it all together. And just like the other one, change the scale method to absolute instead of extents. There are 10 outside points and there are interior points. So now we can use the next awesome node from PCGEx, and that is the cluster node. If I search cluster, you'll see there's a bunch of different cluster nodes. There's tons of them. What we're going to be using is cluster Voronoi 2D. So go ahead and select it. And then I'll take this merge point and I'll plug this into the in. If I go ahead and press D on this node, you'll see already we have a very thin outline here of a 2D Vornoi pattern. Now, it is very difficult to see, so we can make it a bit easier. There's a new node called debug edges. Now, when searching for it, it's not debug VTX, which you might think you want to grab for this one, but in fact, it's called debug edges. So keep that in mind when you grab it, and you just plug in the vertices and the edges into these both. And now in this node, on the parameter overrides, we can change the radius here to something like 10. And now without even having to press D, you can see it is now considerably easier to see the shape here, which is fantastic. So now we have a big cell in the middle, and a bunch of little ones. And if we want to, we can go ahead and move these around and control where they go. And you can see the shape automatically updates. But here's the thing. You might look at this and be like, okay, so we now have our points as scaled points. Isn't that right? Because that's what we're seeing. And the vertices are probably the points here. So not quite. So the vertices are indeed the points in the corners of every shape. That's kind of the connection points. So this one here, this one, these are all vertices. And I can show that to you, but just adding a debug to the vertex only and setting it to absolute 2. So you can now see that, yes, we are getting a point basically everywhere. Well, it makes sense for a vertex if this was a polygon to appear. But don't confuse the edges as actual scaled. If I debug the edges the same way I just did the vertices, well, here it is. It is just a single point in the middle. You can see the bounds haven't changed on it. Is just in the middle and it's just facing the correct way. Vertices and edges are just points. Nothing special about them. The one thing that's different really is that the debugs understands that, hey, make the edges appear long ways, but it doesn't actually stretch the information for you in terms of the bounds. Under the hood, everything is a point, a regular, simple point. And because it's a point, we can do some interesting things. Now, this is not going to be used in this tutorial right now, but I'll show you a nifty node before we continue on. After this Voronoi 2D, I can drag out a vertex and search for find contours. It's right here, PCGEx pathfinding, find contours. And if we take the vertices, plug into vertices, edges into edges, and sides into seeds, again, this is the same kind of seeds here as this one. It is not, again, the point seed, the random number of it. I can then use a debug paths node and take a look at it more closely by changing the radius here to something a little bit bigger, let's say 10, to make it nice and visible. Again, it looks like just like the old paths that we had, the same shape, same everything. So what is it doing? Because everything looks the same. Well, if I go back to this debug paths and I open the parameter overrides, we have the radius at 10, but if you go down, there's an apply offset option. If I enable that and change the offset to something like 100, you will really see what is going on under the hood. These are, in fact, their own pieces. They've separated out. If I make it something like 500 here, you can really see how each cell has separated. And because it's a path now, a path is just points in a line that you can really easily use to create a spline from, because they're already automatically in order. So from paths, instead of debug paths, I can do create spline, and I can change it to create component of type closed loop and linear. And you can see in the world, we now have splines that are in the positions of all these points. So if we wanted to, we can already just use a spline mesh on these if we wanted to. Now I'll be showing you how to spawn regular meshes that just fit to this right size. But if you wanted spline meshes in these positions, you can absolutely already use this, offset the actual splines, and have some fun and use this. I just want to throw that in as a little bonus there, because I found this to be really cool. But again, we're not going to be using fine contours. I just wanted to show you guys this nifty node. So going back to the regular Voronoi 2D. From here, I want to use another new node called Edge Properties. And as it says in the description, it extracts and writes the extra edge informations to the point representing the edge. So if I take the vertex into the vertex, again, edges into edges, if I go under solidification, I can give it a solidification axis. For example, the x-axis, which is forward. Now, at this point, you'd be like, okay, well, that's not very many options here. Well, here's the thing. This node's a little bit buggy. By that, I mean, you do deselect it and reselect it. As you can see, we just have this area of solidification here. If I deselect it and reselect edge properties and go back to solidifications, we now have this whole section called radiuses. And now we can write radius Y and write radius Z. And what does this mean? Well, let me show you. With those both on at constant, this is what our actual section looks like here. It's very tiny. But if I was to change Z to, let's say, 300 and Y to 50, watch what happens. Now our points are much thicker. And again, they're the 50 in width, 300 in height, and X being the forward vector is how it's connecting. So now you might be seeing, okay, now we're taking the points that were just originally just simple squares, and we've now actually given them the thickness and the size that we were seeing with the preview edges node, all thanks to this edge properties node. Because again, as you recall, if I debug just the edges with a simple demug node set to absolute, and let's say just be 5x to really make them big, right? You can see the original point here is just a single point quite large in the middle of these. And this is still a regular debug. It is not a special debug, as you can see with the icon here in the top left, but now we're seeing the full extent of it. Fantastic. So because we already have the vertices and the edges here split up, I can use a simple transform points node and then a static mesh spawner. With a static mesh spawner, because this is going to be our vertices here, I'm going to just specify a simple cylinder shape here, and I'm going to make the shape 10 times bigger in all directions so we can really see it. And just like that, we now have a cylinder in every single location here. So fantastic. We already have some information that we want. Now, if you come back here and try to press D at this point onto edge properties, you will not actually see the debug for whatever reason. If you don't have anything plugged in here, then you see the debug just fine. But as soon as you plug it in, it goes away. And the easy way of getting edges back, though, is just to use a simple debug node, a regular one, and you'll see there's our edges back. So now how do we get something spawning inside of these locations? I want to now connect all of these. Well, because it's regular points, you can absolutely just spawn whatever you'd like and modify it to the bounds of the points. Because as I mentioned, thanks to the node, we've changed that single point into what we actually want. But that's extra math. And I don't know about you, what sounds more awesome and extreme is for it to do the work for me. That sounds a lot better to me. To do that, we will need a new thing. And that new thing we're going to need is a data asset. Under miscellaneous, I'm going to grab ourselves a data asset. And then it wants to select the data asset instance. And you can see some new ones, PCGEx ones right up top. We want the mesh collection here. I'm going to go ahead and select it. I'm going to call it PCGExMC for PCGEx mesh collections _ walls. I'll open it up and you will see this new screen here. Now, don't be afraid. It's relatively simple to use. I'm not going to go over every single button here, but I'm going to show you what you need to get things working. So here in the top left, if you have something in the world you want to add, you can just click add selection. But in our case, I'm just going to use a new entry here. I'm going to add it. I'm going to open it up and we can already specify a static mesh here. In my case, I'm going to use a simple regular engine cube. Now, a lot of this will look familiar to you. For example, you have the ability to give it a weight because you can add multiple things. For example, I can add a cube here and a pyramid. I can give the cube a higher weight, in which case it will automatically appear more often than the pyramid. I can also give it a category, some tags, things of that nature. But honestly, for now, this is all I want. I'll go ahead and remove the pyramid after I show you how this exactly works. But as soon as you're done with this, you're not quite done with the mesh collection. What you need to make sure you do is click the rebuild station button and then hit save. And now we can go back to our actual PCG graph. I'll go ahead and remove this debug and instead we'll use a new node called asset staging. This node called asset staging will take your asset collection, so you can go ahead and select it from the drop down there, and I can use the edges here in the in node. Now in this node, you also see the asset path attribute name. So this is the node that you will be using to spawn with. So what I mean is, if you drag out a static mesh spawner, on this one, you need to change it from weighted to by attribute here. And we want to grab this asset path attribute name and plug it in right there. We can of course change this name to, let's say, walls, and change the static mesh spawner to walls. That is simply fine. It is just whatever you'd like to call that attribute. And if we take a look, well, we have pyramids and cubes, but they don't quite match the shape. And that's okay. We haven't configured it yet. Back in the asset staging, we have quite a few options. We have scale to fit. And just like before, instead of scale to fit minimum, I want scale to fit fill. And as soon as I do that, well, would you look at that? It has now fit our pyramids and our cubes to fit exactly inside the shapes that we have specified. And that looks pretty good. Now you can see what's happening. Again, with a 5:1 ratio, we have more of the cubes than we have pyramids. But of course, we don't want this pyramid shape here. So what I'm going to do is go back to our mesh collection and I'll delete this index one. But of course, do not forget to click rebuild staging and then hit save again. And also, you're not going to see it update right away. All you need to do though is click force regen in the PCG graph here, or in your PCG component, just click cleanup and generate. And you'll see you'll get all of the walls back as you'd like. So fantastic, this is working, but they're not quite in the correct area relative to the cylinders. So let's fix that a bit. Still in this asset staging node, our next section is justification. You can see justify X, Y, Z. And if I open justify Z, because we really need to update the height, you can see how this is going to affect things. If I move this over to the left, so we can take a look at both together. If I change this 2 on the justify Z to minimum, well, would you look at that? It has gone to the bottom. If I go with max, it has gone to the top. Now, it might be hard to understand what is going on here. So what I'm going to do is from the edges, I'm going to use a simple debug here. Where I'm going to change the point mesh to a 3mm box here. And I'm going to give it a different color to make it really stand out. So now you can see the center of this mesh that we're spawning here is at the maximum location because that's where its pivot is. If I say center, it'll put the center of the center. We can say minimum here, and it'll put the center of this at the minimum. If I say minimum, then the minimum of one will be the minimum of the other. But if I say minimum to maximum, it gets it put right above. Because it goes the minimum of the shape you're putting in compared to the maximum of the original bounding box, basically, of this point. Now, if this is confusing, don't worry. You can play around with it. There's also a page for documentations on fitting here, where if you scroll down, you can see here's a bunch of scale to fits. Here's what it does. And here's the different justifications with nice pictures to really explain things. You can see this is under general fitting here, in case I forget to link it in the description. So this is cool and all, but I guess in our case, I want it to be at the minimum of the cylinders. Now we have two options. We can either move the cylinders up or we can move these down. I'll kind of show you a combination of both by moving these down. But we don't know how much. Instead of what it is right now, I can change it back to center here. And the 2 I can change to custom. Now custom by default is 0.5. 0.5 is the middle. And it's relative. If your height is 1,000, then the middle is still 500. If your height is 100, center is 50. It is proportional. It is not an absolute value. So keep that in mind. But now we can go ahead and just take this 2 and just drag it a little bit down. And then when we let go, you can see it has moved down. So now we have it around where we want, maybe around 0.17. That seems like it actually is right on the ground there. And we use a constant custom here. So now if I remove this debug, you can see we now have all of these points here. And if we wanted this all to be higher up, all we need to do is take the PCG graph and all of our center points together, and we can just move it all up. And you can see it all comes up nice and easy, and we can put it on the ground level. So this is awesome. We can now already play around with this. We can, if you want, add some more points even. As you can see, duplicating around our cell centers, we get more interesting results in areas we want. And you can see they're not exactly in the center of these, but they kind of get you a guide to around where the pieces will be. If you want to get the center exactly, if you debug these sites here from the Voronoi 2D by using just a simple debug here, again, I'll set the absolute value to 5 for these debug points. You will see the debug values are actually in the center of each of these cells. So if you want to spawn something exactly in the center of every one of these points, or just know where the kind of the centerpiece that started this calculation is, that comes from the sites here. Which again is why we plug the sites into the seeds, because that's where everything kind of split off. So fantastic. We now have a basic Vornoi. We're spawning meshes where we want. They're scaling the way we want. All is working well. So now what if I want to cut something out? I have a simple cylinder shape that I want to cut out in an area. How do we do that? Well, first of all, we need to have that area in the world. So I'm going to just go ahead and create a simple cylinder shape, and I'll put it here in the world, and I'll scale it up quite a bit. And then I'll want to push it down at the same elevation as the rest of these points. And if I take a look at them, I've moved them up to 520 in Z. So I'll make sure this one is also at 520 in Z. Now, the only downside to this is it is very difficult to see through it. So I'm actually going to change this cylinder to a 3mm circle. You can see here, control rig, circle, 3mm. If I go ahead and select it, you can see we get this lovely circle here, which is much easier to work with and select with. And of course, we're going to need to find the circle in the world. In case we also have multiple, we need to select multiple of these in the world. So what I'm going to do is, with our circle selected, I'm going to go to tag, and I'm going to give it an actor tag. And I'm going to give it a tag of hole, because that is where I want the hole to be. And now I can go ahead and duplicate another one around and make it bigger, for example, over here to really show you how this is going to affect things. So similar to what we did before, I need to generate a circle, but this time this is our actual bounds instead of the full size. So what I'm going to do is take this create shapes, circle, and get actor data. I'm going to duplicate it down here. The create shapes and circle, we can leave as is, but this get actor data we need to change. I'm going to change the actor filter to all world actors by tag, and we want to give it the same tag, so whole. And we're going to turn on select multiple. So now if I debug the create shapes again, and set it to be absolute point scale of 3, you see that our shapes are now filling in nicely, and there's our circles, nicely created and nicely following this area. Now we want to filter out everything that it is overlapping. But first, we need to basically combine the two. And to do that, we need to convert the shape into a cluster. Now, because of this create shapes is already a path type, which means that the points are in order. So if you want to create a spline from it, you can already do that. We're going to use the path to cluster node. As you can see here, PCGEx path to clusters. If I go ahead and select it, we can leave it as is. We don't need to change absolutely anything on it. You can see we have a few options here like fuse paths. We can find point edge intersections. We have a few things over, but default is all we need on this one. Because the main reason we want this is to combine with the Voronoi 2D. So now I'm going to detach this edge properties here. I'm going to push this over to the side. And then we're going to use a cluster fuse node, which is going to fuse one with the other. So if I drag the vertices and edges from one, and the vertices and edges from the other, we go ahead and fuse the two together. So if I go ahead now and do a debug edges, plug the vertices and the edges through here, and go to parameter overrides, radius, and change the radius to, let's say, 50, you could see now we have the actual information from the original, as well as the information from this one right here. So now that we have that, we just filter it out. I'll drag out of vertices and just search for filter. And you'll see we have a lot of filters here, and I mean a lot of filters. The one we want is this, cluster refine. You can also search for filter cluster, and then you can find it much easier by here, cluster refine. And here's the thing, that's not where the filter is selected. Here in the detail panel is where we can specify the refinement type, and you could choose a lot of different ones. Shortest, longest, just the refine filter, overlapping, remove longest, remove lowest score. There's tons of it, and there's documentation on the filters also available online, so you can check it out if you'd like, but we're going to go over the one we need in this scenario, which is our refine filter. This gives us an edge filter right here. So what is it what we want to filter out? Well, we want to filter out the shape that we created. So what we're going to do is take the points from the create shapes, and then we're going to use a path offset. Now, the reason I grabbed this is because the filter that we need for this edge filters requires an input of points. And that filter is polygon 2D inclusion. You can find all the filters if you just search filter. As you can see, there's tons of them. And it's near the bottom here under polygon 2D inclusion if you want to grab it that way. And you can see it requires paths, which is why we converted our create shapes into paths with a default offset because we just effectively wanted it a path. So we can take that, plug it into inside polygon, and we can plug that into the edge filters. Now in my case, I seem to have forgotten to plug in the edges, so I'll go ahead and plug that in as well. So now if we go ahead and drag out of this refine filter, we could go ahead and debug the edges here as we did before to take a look at them. We'll change the parameter overrides radius here to be 100. And if we take a look, well, I think we have the opposite. We want to remove this part, not only keep it. So all we need to do is on the inside polygon, we need to turn on invert. And when we do that, you can see it has removed the connections here between the different pieces. Fantastic. So now that that's working, we can do a similar thing to what we did here. So I'm actually going to just duplicate this over here in case I want to reuse this for a later point so I can preview it. I'm going to plug in the vertices, edges into edges. I'm just going to change the edge properties here under solidification, radiuses to be 400 in height because I felt it was a bit too small. And on this version, I'm going to do the offset on the transform points for the cylinders by moving them 600 units up. And I'm going to scale them by 20, but only in the Z axis. But of course, for that, I need to turn off uniform scale. And the only other thing I'm going to do is on justifications, justify Z, I'm going to reset this to custom. I'm going to put it all back to default with center and same, because in this case, we're moving the cylinders up compared to moving the walls down like we did right over here. And if we take a look now, you could see that the points where they were connected are now gone. And if I want to, I can now select this circle, make it bigger, and it will cut things out. Now you might notice that it's not quite cutting things out enough, right? It's maintaining this point. And unless I really overlap this point, it doesn't quite cut it out. And also, I'd really like the point to be here, right? Because that's the area I want cut out. So the last thing we can do here is under this fuse node, we can turn on point edge settings and edge settings. If we just turn those on, you will see immediately that now the points are actually cutting out and they're stopping at the circle that we have created. So if I move it over, of course, the pillar goes right up to that edge and then stops. Same thing here. It goes right up to the edge and stops. And if we want to add more, we can, of course, add more and cut them out. Wherever it gets to is where it will stop. It might be a little easier to see without the cylinders real quick. So as you can see here now with just the walls, everything stops exactly where they're connecting to these circles. And because we did this by offsetting the cylinders versus offsetting the walls, you can see it all lines up really well. But for those of you that have stuck around with me to the end, I want to show you one extra little bonus thing that you can actually do with this. And that is if we take any of these points, we can technically move them up and down a little bit. If I move it up, you can see it does move the actual section up and down. It's not going to be completely overriding it, but we can indeed move some sections up, some sections down. But of course, as you can see here, because we move this one down, it no longer overlaps as well with this circle. So just keep that in mind. Depending on what you're doing, you might need to keep some of them in place, but there is some playing around with that you can do by moving things up and down, as you can see here. So now by moving that one up, we have now made this little cool connection here between these. Now, I know it is a lot to take in. PCGEx is extremely powerful, but very dense. But once you just kind of learn it, even the small basics that I've shown here, you can start incorporating it to your projects and making them just that much grander. And if you'd like to see more of PCGEx tutorials, please let me know in the comments below. And let me know what part of PCGEx really excites you to learn more about, and I'll see what I can do about teaching you that next. As always, the project file for this will be available on my Patreon, where you can join these wonderful people here. It really means a lot. And if you'd like to join the community, the link to the Discord will be down below as always, along with the PCGEx Discord and any other links I can supply to you guys to help out. A big thank you again to Tim for creating PCGEx and the help with this tutorial. If you've never seen PCGEx before this video, then check out this video right over here where I go over the many things PCGEx can do.